Okay, right now what we're doing is we're going to mass out the apples. First you have to turn on the scale. You have to get it to 0. Alright, now that it's at 0, we're going to put our first apple, Gallo 1, right on the scale. Once it gets to the final number, you just write that down in your journal. Now, and we're going to do this 3 times. Sometimes it's not going to be at 0, like right now it's at negative 0.1, so you have to re-zero it. Alright, and for the second try, we're going to put it upside down. We're just going to mass it out at different angles. Because right now it's actually 0.2 grams higher, or larger, heavier. For a third take, we'll do it like this. Alright. And that's how we're going to do it for each type of apple. This is Gala type 2. We're just going to upright, put down the number, get it to 0, upside down, now what we're going to do is find the volume of the apples. With the 1,000 milliliter beaker, the 1 liter beaker, I fill the water up to 600 milliliters. And we're going to use Granny Smith. So this is GS1. Just submerge it in the water. And since it's an apple, it's going to float. So we're going to use a little screwdriver to push it under. So for each 100 milliliters is 20 gradations. This apple, after being completely submerged, is 9 of 20 gradations. That would be 945. The actual volume of this apple is 945 subtracted by 600 milliliters, which is 345 milliliters. And now you're going to put that in your book. You're going to take out the apple. Take out the apple. Dry it off, because you don't want any extra water added to the volume. And make sure this is at 600, which it's not. So we're going to have to add some more water. Okay, so now that the apple is completely dry and we got the water meniscus back at 600, we're going to take our second try with the same apple, put in the water, completely submerge it. This time, the apple water meniscus is actually at 950. So, I'm going to write 950. Take out the apple and re-dry it. Water's not at 600, so we're going to have to go over that process again, add water, and completely dry. What this is a refractometer. You can use it to measure the sugar content of apples or things that have juices in them. How you calibrate it is you use distilled water. You get in the eyedropper. You place 2 to 3 drops on the lens. You close this up, and you look through, and you make sure it's at 0. The level right now is not at 0, so you just use this little screw. You use this little screw, and you just twist it until you get to 0. When you want to find the sugar content of the apple, you have to make a small incision into the apple.
Look at this.
So you can get the juices coming out. You use an eyedropper, you just suck it out, and like the distilled water, you place 2 to 3 drops on the lens. Alright, ooh, look at that. Okay. Okay.
Close it up now.
Now, close it up, you look through, and it's going to give you a number between 5, 10, 15, 20, 25, and 30. And there's little gradients between them. So that's going to give you a decimal number or a whole number. Close this up. Press it down. Ooh. This one, 13. It's on the 4th dash mark. What we're doing now is we're making a table or a model for everything that we got, all the data we have. Right now we're doing weight. So what you're gonna do is you're gonna make a table for gala. You're gonna categorize it by weight. You're gonna have 3 columns for each weight take that you have, and you're gonna put it down from lowest to highest. There's a 4th column that gives you the optimal weight of each sample. At the end of the table, it gives you the optimal weight for gala, the entire type. So you're going to make one for each sample. And for volume and sugar content, it's the same aspect. It's the same idea. It's the same table structure, just different numbers. And with the Monte Carlo summarization, that will give you a graph. The 90th percentile is showed by this little triangle up here at the top, which is 254.14, because we're going to round it up. So that's the optimal weight for gala. And for the volume and the sugar content, it's the 90th one is right there. So for each sample, for each weight, volume, and sugar content, that's what you're going to take as a number. So what I'm doing is using a PERT method of simulation, and these are the input results that the method gives you. These are the output results: the min, median, mean, the max, 5%, 90%, which we're using, and then these are just the results or the facts of the graph that we got. And once again, it tells you 90th percentage. It just tells you extra information that you can use. It has the mode, the median,